Notice how a tense meeting can quickly alter appetite, bowel urgency, and stomach sensations within minutes. That rapid shift points to a network where gut signals shape emotion, and emotion reshapes digestion. The core mechanism involves bidirectional signaling through nerves, hormones, and immune molecules traveling between gut and brain. Sensations rising from the gut reach brain circuits, and brain commands adjust motility, secretion, and pain sensitivity. Because these signals influence emotions, they can amplify anxiety, numb mood, or sharpen intuitive decisions. When that loop becomes noisy, ordinary sensations can feel threatening, and digestion may swing between stagnation and rushing. Consider a morning when stress begins before breakfast, and the gut clamps down or empties abruptly. Later, another day feels calm, and the same meal passes smoothly with little conscious attention. In the next few minutes, we will map the pathways, the stress switch, and diet patterns that reshape microbes. This video is inspired by the mind-gut connection by Emeran, and subscribe to follow more practical guides on gut-brain health. Gut sensations are continuous interoceptive reports that inform the brain about internal conditions every millisecond. The brain integrates these gut signals with other body signals to maintain balance and readiness for threats. Since the gut sensory network is vast, subtle shifts can produce loud sensations. When sensitivity rises, normal stretching or gas may be interpreted as danger, prompting more intense brain responses. After a rich meal, one person might feel mild fullness while another experiences cramping and urgent bathroom trips. The difference often reflects how the brain filters incoming gut signals, not just what the gut contains. Understanding this feedback helps explain why emotions, attention, and digestion change together throughout the day. It also clarifies why fixes that target only the gut can miss the brain's role in the loop. A useful next step is tracking when sensations spike, what emotion is present, and what context preceded them. Then, treat the pattern as information for calming routines, not as proof that something is immediately wrong. The vagus nerve serves as a primary pathway, connecting gut receptors to the brain, carrying most signals upward. It is bidirectional, but most signals flow from the gut to the brain, influencing mood, appetite, and pain regulation. Microbial activity can affect this pathway, and animal studies show that cutting the vagus nerve leads to loss of emotional effects. This suggests that the brain may respond to microbial cues without conscious awareness, long before any lab test shows abnormalities. A diet high in animal fat can increase gram-negative microbes, whose cell wall molecules activate immune cells beneath the intestinal lining. These immune signals can travel to the brain, including via vagus nerve terminals that detect inflammatory molecules. This links digestion, barrier function, and feelings like fatigue or low mood into one interconnected system. It also reframes some symptoms as communication failures, where signals are amplified rather than invented. To support the barrier, focus on fiber-rich foods that improve mucus defenses and reduce microbial contact. Pair that with consistent meal timing and sleep to ensure the nervous system receives clearer, interoceptive signals. Stress responses start in the brain, and a key chemical switch, corticotropin releasing factor, can push the whole body into alert mode. When threats are perceived, the hypothalamus releases CRF, which increases anxiety and heightens sensitivity to gut signals, making belly pain feel more severe. CRF also changes gut movement and secretion, accelerating evacuation or slowing the stomach depending on conditions. In some stress spikes, the gut contracts and empties quickly, producing diarrhea and urgent cramps within a short window. In other spikes, stomach emptying reverses toward vomiting, while the gut wall becomes more reactive and leaky. Because stress also shifts microbiota composition and activity, repeated activation can keep the loop unstable over time. This explains why symptom cycles can follow life events, even when standard tests fail to reveal structural disease. A practical step is to build a stress interrupt that lowers arousal before meals, like paced breathing and a short walk. If stress-driven gut swings sound familiar, then subscribe to learn simple routines that calm the brain-gut loop. If stress-driven gut swings sound familiar, then subscribe to learn simple routines that calm the brain-gut loop. Serotonin-containing cells in the gut help translate mechanical and chemical events into nerve signals. Under normal conditions, gentle forces from moving contents release serotonin, which activates vagus endings and the enteric nervous system. This activation informs peristalsis and timing, keeping digestion coordinated without conscious effort. When the signal becomes concentrated, the same machinery can trigger vomiting or intense bowel movements as a protective evacuation. A toxin binding to receptors on serotonin cells can flip the setting toward rapid diarrhea and repeated vomiting. Even after recovery, the memory of those sensations can stay vivid, shaping future fear and anticipation. This demonstrates how gut sensations are not only physical events, but are also recorded within emotional circuits. It also explains why some treatments target serotonin pathways or vagal stimulation to alter the signal itself. The next step is to separate true poisoning or infection from learned alarm, then respond with appropriate medical care. For everyday discomfort, aim for regular sleep, predictable meals, and reduce stress arousal to stabilize serotonin signaling. Diet is a major lever because it shapes microbial diversity, abundance, and the chemical products microbes create. A plant-focused pattern with complex carbohydrates, plant fats, fish, and fermented foods supports healthier microbial communities. High animal fat and low-fiber patterns can thin the mucus barrier, increase leakiness, and provoke immune activation. When wall molecules like lipopolysaccharide engage immune cells, cytokines can signal the brain through vagus terminals. Some diets reduce akkermansia, weakening mucus production, so microbes sit closer to the lining and trigger reactions. Other diets emphasize fiber, nuts, berries, and olive oil polyphenols that correlate with more favorable microbiota profiles. This connects food choices to mood and brain function, as immune activation and vagal signaling influence pain and depression. Traditional patterns in Mediterranean and several Asian cuisines share communal meals and frequent fermented side dishes. A practical shift is increasing plant variety, adding naturally fermented foods, and reducing refined sugars and processed foods. Keep the plan simple by repeating a few meals that fit this pattern, then gradually expanding your options. The main shift is treating digestion, mood, and immunity as one interconnected ecosystem rather than separate issues to address. This ecosystem operates through bidirectional signals, so changes on either side can improve or worsen the overall pattern. We explored constant gut sensation traffic, the vagus and immune messaging routes, and the CRF stress switch. We also delved into serotonin-driven evacuation signals and how diet remodels microbes, barriers, and inflammation. When these components work together, sensations become clearer, anxiety decreases, and the gut handles meals with less turbulence. A healthier microbiota and barrier reduce immune activation, which can lower fatigue and pain sensitivity. Start with one change this week, either increasing fiber, incorporating fermented foods, or taking a daily stress break. Pair it with consistent sleep and meal timing, as nervous system rhythms significantly influence how signals are interpreted. Over months, the goal is to reduce surprise flare-ups and gain more confidence in reading what the gut is communicating. If you want more practical steps for connecting diet, stress, and symptoms, then subscribe to continue learning with each new video.